Welcome, third graders. This is Mrs. Friedberg, and today we're going to talk about partitioning shapes. So, breaking shapes into different parts. The materials you're going to need is a pencil, your math workbook, pages 871 to 874. So, partitioning shapes. How can geometric shapes help me solve real world problems? Well, let's take a look. Math in my world. Example 1. Victoria will plant 4 different vegetables in her rectangular garden. If she wants to partition the garden into 4 equal sections, what fraction of the garden's area will be used for each vegetable? So we have 4 different vegetables, and we have 4 equal sections. And our question is, what fraction of the garden's area will be used for each vegetable? So what we're going to do is draw a rectangle. And because it's a rectangular garden, I'm going to box that one. And we're going to divide it into 4 equal parts. The best way to do that is to go right to the middle first, and then middle of that, and middle of that one. So now we have a rectangle with 4 equal parts. So we're going to partition the rectangle into 4 equal sections and explain how you partition the rectangle. So, like I said, we first drew a line in the center, creating 2 sections, comma, and then split those in half. So, what unit fraction of the garden's area will be used for each vegetable? So remember, we have 4 vegetables, and if we used our unit fraction, we have 4 1/4 sections. So each vegetable would have 1/4 of the rectangle. Excellent. Turn the page over. Now we're going to talk about hexagons. Cool. Example 2, partition a hexagon into 6 equal sections. What fraction of the hexagon's area does each section represent? Now remember, a hexagon is a 6-sided figure. So we're going to definitely circle that information, and then we're going to underline our question. So a hexagon is 6-sided. So we have 3 on the top, 1, 2, 3. And then we have 3 on the bottom, 1, 2, 3. And the way we break this down is into 6 sections. So I'm going to draw a line through the half. Then I'm going to go from this corner to this corner. Then I'm also going to go, and so if you actually turn it, you're actually going half here. And then we're going to go half through the center, creating 6 parts. So the first partition the hexagon into 2 equal sections, and then partition each section into 3 equal sections. So what unit fraction of the hexagon area does each section represent? Well, remember, now they're talking about unit fractions. So 1 of 6 parts, or 1 of 6 of the total parts. Great. Let's look down below. Math talk. Explain how you would partition a pizza so that you and 7 friends each get an equal share. So we definitely need to think about that, especially if we have like a circle and we have an uneven number. That's not as easy as when we have an even number. So let's look at our guided practice. Partition the circle into 4 equal sections. What unit fraction of the circle's area does each section represent? So again, remember, we're going to partition the shape in half. And then if you think about it, you're going to partition that in half as well. So each of these, again, is a unit fraction of 1/4. So each section has an area that is 1/4 of the total area of the circle. And again, go ahead and try it on your own and see if you can come up with a pizza that only has 7 slices. So turn to page 873. And you're going to partition each shape or each figure as indicated, and then write the unit fraction of the figure's area that each equal section represents. So again, remember, you always kind of want to start with half and then half of that and then half of that, depending on how many sections you need to have. And remember, partition means to divide the shape. So I always like to think of food. And so if I have a lasagna casserole and I need to have 6 equal slices, again, we start in the middle. And then because we're going to need 3 on this side and 3 on this side, I'm going to kind of look and see where I'm going to need those. And I'm going to draw my lines. And remember, if there's 6 equal sections, that's your denominator number. And if each section, we want to know what one section, remember, so if we had to label all of these, we would have 1/6 all the way over, till we equal 6/6. So one part would be 1/6. 2 equal sections. I bet you could figure that one out. 2 equal sections here. Now you could do this one several different ways. Remember when we cut the hexagon in half and half and half on the other side, you could go from here, you could go from here, or you could go from here, or you could go straight down the middle. There are many options. 6 equal sections of a circle. So you're going to need 3 on the top and 3 on the bottom. So again, you're going to want to, and then a third, and then a third. So what I like to do, I like to draw a line across the center, and then if you turn it, you could draw another line across the center, and if you turn it again, you have another line across the center. Woo! Making you dizzy. So we have 1/6. Because remember, your 6 is your total number of parts. 3 equal sections, 8 equal sections. Now let's look down below. Draw a square, partition it into 4 equal sections. What unit fraction of the whole represents the area of each section? Underlining our question. We're going to, this is what we're going, the important information. We're going to draw a square, equal sections. Great. And what type of math are we doing? We're going to partition it. So we're going to draw a square. And you're going to draw it. Remember, you want to cut it in half. Then you cut those halves in halves, giving you 1/4 unit fractions. So what unit fraction of the whole represents the area of each section? So that would be 1/4. Great. Now you're going to draw a rectangle and partition it into 5 equal sections. So we're going to draw a rectangle, 5 equal sections. What are we doing? We're partitioning. What's our question? What unit fraction of the whole represents the area of each section? Just like we did there, but now you're going to do it with a rectangle, and you're going to have 5 equal sections. Turn your paper over. Looking now at the problem solving. Loretta and her 3 friends are helping paint a rectangular wall in the school. They decided to partition the wall into 4 equal sections. Each friend will paint 1 section. What unit fraction of the wall's area will each friend paint? How many friends? 3 friends. What's our shape? It's a rectangular wall. They decide to partition. Partition is the type of math we are doing into 4 equal sections. And then our question is, how much will each friend, what unit fraction will each friend paint? So if we have our rectangle and we cut it in half, making 2, that'd be 2 for our friends. Cut that one in half and we cut this one in half. We have 4 equal parts. How much would each friend paint? Each friend, friend would paint 1/4. Now, Colton's here. Great. He's always showing up in this math book. Colton drew a pentagon and he partitioned the pentagon into 10 equal sections. What unit fraction of the whole represents each area? So he drew a pentagon, 5-sided shape, partitioned is the type of math, into 10 equal sections. Our question is, what unit fraction of the whole is represented? Now, does it say you have to draw it? No. Could you? Yes. Do you have to? No. But I know that 10 is my total number. And I know that what unit fraction of the whole represents each area. Well, we're only going to talk about 1 unit of the whole. So we can say 1/10 represents each section. The area of each section. Excellent. Now, some hot problems. Math practice. Make sense of problems. The area of a rectangular piece of fabric is 24 square inches. The fabric will be partitioned into sections of equal area. Each section will have an area that is 1/4 of the total area. How many square inches of the area will each section have? So, we have a rectangular piece of fabric that is 24 squares. So I'm going to think of a number, a factor that equals 24. You'd equal 24. And I remember that area, that's here, 24 square inches into 1/4 of the area. How many square inches of the area will each section have? So I know that it's 1/4 of the area. So I know that it's something times 4 is going to equal 24. Because remember that area equals length times width. So here's our area already. So we already have that answer. And we know that one part of it, probably the width, is 4. So 4 times what equals 24? So if I have a 4 here, and if I were to cut this up, 4 times 6 equals 24. So how many square inches of area will each section have? Each section will have 6 square inches. Circle the figure for which each section represents 1/6 of its total area. So now we're looking for any shape that has 1/6 or 6 unit fractions. So the easiest way to do that is to count them. 1, 2, 3, 4, not that one. 1, 2, 3, 4, 5, 6, 7, 8. Nope. 1, 2, 3, 4, 5, 6. This. Definitely. 1, 2. No. Looking down at the final question. Building on the essential question, how do I partition shapes into parts with equal areas in everyday life? Well, I always like to think of food. And so it could be maybe a cake. So I would make sure shapes of a cake or slices of a cake, I could create, equal slices of a cake. You could do it with a pie. You could do it with many things as long as you're talking about equal portions or partitions. Excellent. Well, have fun exploring shapes.